Hi there, welcome to your lesson on cumulative frequency. Let's get started here. In the last lesson, we were looking at different ways to present data. We know statistics is all about gathering data and then analyzing it, presenting it. We looked at last time different ways of presenting data, and they were included a histogram, a circle graph or pie chart, a box plot, cumulative frequency curve. In the last video, we specifically focused on histograms and box plots. Now we're going to look at the third major way of presenting data for univariate data, which is called a cumulative frequency curve. So we're going to focus on this one here in this video. So our goal is to create and apply cumulative frequency curves, and this is what they typically look like. On this axis here, we're going to have the cumulative frequency, and on this one, we'll have whatever variable it is that we're looking at. Okay, these curves show how data in a data set accumulates. That's why we have the name cumulative frequency. It shows us again how data accumulates. Okay, so here is how we will begin looking at this. Consider the frequency table here, and then look at the curve we have here. So this table shows the number of lost pencils by students. So for example, one person lost 0 pencils. And let's say here, 4 pencils were lost by 6 people, or 5 pencils were lost by 8 people. So this is the number of people or frequency, and this is the number of lost pencils. Now, looking at this graph, does it match our table here? Let's take a look. One of the first points on the graph is 0, 1. Well, we see 0, 1 here. Okay, maybe that matches. Let's look at the next point. The next point is 1, 2. That point, well, 1, no, not 2. So what's going on? Next point is 2, 4. Right here, 2, 4. Is that the next value? 2, 4? No, so something's off here. Obviously, this graph is not a representation of frequency values. But again, let me remind you, this is called a cumulative frequency curve. So we're going to add another column here where we accumulate the frequencies. So if we look at just the top row here, we have a total number of frequencies of 1 so far. But then as we go here, now we have a frequency of 1 occurring again. So now we've had in total 1 and 2. So this is like a total column. Okay, and then we add 2 more data points here. 2 pencils lost was 2 people. So now if we have the total, we had 2 before, we have 2 more, now it's 4. And the next one here, we're adding 5 more to our count, which brings the total up from 4 to 9. So notice this is like our total column. And that is exactly what's being graphed here. That is called our cumulative frequency. It is this running total on the frequencies. And you see by the end you get a value 50. That means your total count of things here, data points, is 50. And you can see now 0, 1, 1, 2, 2, 4. Those are the points we plot to create our curve. So that's how you make a cumulative frequency curve. You plot the data point and the cumulative frequency at that data point. Okay, so what does this graph tell us about the number of students losing pencils? Well, I hope you thought about it a little bit and looked at the shape and you're like, okay, so as we move up here, 1 pencil, 2 pencil, not too many students are losing that many pencils, but then this slope gets steeper, and as the slope gets steeper, it tells us there's a quicker accumulation of number of people that are losing that many. So by the time we get to 3 or 4 or 5 pencils lost, we're adding larger numbers to our cumulative frequency. That means there's more and more people that lose this many pencils. But then the curve curves down again. It slows down and curves down. That means by the time we get to 8, 9, 10 pencils, there's not that many people we're adding each time. And we can see here also, not that many people there. Most of the accumulation happens in the middle. All right, second question. Why will a cumulative frequency curve never curve down? All right, so you notice it curves up, but it's never going to curve down. Like it's never going to go down again. Why? And it's also never going to go left. Why is that? Well, it's never going to go down again because that means you would be subtracting from the cumulative frequency, but you're not. You're always adding these values, and this number is always going to grow. So it can't shrink again. And you can't go left because you're moving through the data set this way. You're not going back in the data set here. All right. So we have just created a cumulative frequency curve for ungrouped frequency data like this, right? We had ungrouped data, but we've in the past looked at data that has grouped frequency. For example, this, right? This is discrete data because you can only lose whole numbers of pencils. This is continuous data, and this is called a grouped frequency table where we have these categories here. And this is for continuous data. For example, time is continuous. So how would you graph these on a cumulative frequency curve? How would you deal with these? Well, in the past when we dealt with these, remember when we had to find mean using frequency tables like this, we said, oh, this goes from 3 to 4, so why don't we just say 3.5, kind of like the midpoint of those categories, and use that to represent things. And that's exactly what we're going to do. And we're going to do it with an example with the game Oware. This is an old game of stones from Africa, great game. And here we can see 50 people played this game, and in total, they had to play 49 games to arrive at a champion. So let's take a look at the table we have. These values in the table represent the amount of time it took for a game to be completed. All right, so 3 to 4 minutes, 2 games were completed in that amount of time. 4 to 5 minutes, 12 games. You can see most of the games took 5 to 6 minutes and so on. Okay, and it says these are the average times it took for 49 games. Now, to create the cumulative frequency, we're going to keep moving along in this table here. Here's our frequency numbers. Here's where we're going to use our upper boundary. So we're not using the middle value, like I said, but we're going to use the upper boundary. So to do cumulative frequency, rather than using the middle, we use the upper. The upper boundary here is 4. The upper boundary here is 5. What would be the values here? Well, clearly those are going to be 6, 7, 8, and so on. But what about the cumulative frequency? Remember with that one, you're just combining the frequency numbers, so 2, the grand total is 2, and then you add a frequency of 12, now the grand total is 14. What would the next one be here? 32. Okay, what would the next two values be here? 7 and 43, because you're adding 11 to your total to get the cumulative frequency up to 43. What would the next two be? 8 and 46. And then let's wrap it up with those. So creating a table like that helps with the cumulative frequency. Now we can basically take the upper boundary here and the cumulative frequency and use those points to plot on our graph. So here's how it works. Here's our first point, 4, 2. All right, upper boundary of 4, cumulative frequency there is 2, so we put a point there. Next one, 5, 14, because our upper boundary here is 5, and our cumulative frequency there is 14, so it goes here. What would the next point be? Well, it would be the 632 point, and the next one would be 743, and so on. If you plot all those points, you have your cumulative frequency curve. Connect it. I didn't do it perfectly here. This should be above the axis here. But connect them, and you have that curve, which shows a slow accumulation, and then quick accumulation, because there's lots of data that take games that took between that time, and then slow down because there's not many games that took a high amount of time. All right, that is a cumulative frequency curve, that easy. Here we see with a cumulative frequency curve kind of plateaus, and it plateaus at the total number of data we have. And in our case, we know there's 49 games that were represented, 49 games of Oware. So 49 is our total, and that's where the curve plateaus. All right, so now let's look at another example. This is a great castle in Scotland. This is Hayley's Castle in Scotland. So let's see some data on this. The data we have is the number of visitors to the castle over 200 different days of the year. And we can see there were 0 to 50 visitors, 16 of those 200 days. And then there were 50 to 100 visitors on 38 days. So now here I'm adding a cumulative frequency column. So what would the numbers be in this column here? Okay, let's check our numbers. There are 104, 140, 172. You can see the numbers are growing because we're adding the frequencies. These frequency numbers were added. And then eventually you get to the end, and it should have your total number, and 200 is the total because there were 200 days we were looking at this data for. Here's the curve that's drawn from that. And now we're going to look at this curve in some different ways. So before going back to Hayley's Castle, let's look at this. When we have a cumulative frequency curve, we can use it to determine our lower quartile, median, upper quartile. These are things we talked about when we talked about data sets and box plots the other day. But now let's look at them in terms of our curve. We know our median is the middle value. In this data set that we see here, for example, we can see that we have a total data set of 100. Remember, where the curve ends like this, plateaus, is how much data we have. So we have a data set of 100. So that means data point number 50, halfway through 100, would be our median value. So see how there's a line here at 50, and it tells us in this data set our median value is 60. All right, because here's data point number 50, and here's the marks. I guess this shows marks earned on some kind of test or something. All right, here's the 25th position in the data set. 25th position in 100 is our Q1, right? Because Q1 is 1/4 of the way through data, and 1/4 of the way through 100 data points is data point number 25. So if I go across like this at 25 and go down, that tells me our Q1 mark on this test, because here's the marks on this test, is 45%. Let's do the same thing for upper quartile, which is Q3. Remember, Q3 was the 75th percent position in the data set, right? Q3 is there, so 75th% out of 100 right here, 75, go across, go down from the curve, tells you that our Q3 value is 70% earned on this test. And meanwhile, our median is the halfway position in the data, again, 50, go across and down, and Q2, our median, is 60% earned on this test. Pause if you need to just consider that a little bit more, but now let's jump back to Haley's Castle data, and let's use the curve that we created for that one here to estimate each value. What is the value of the median? All right, in this case, the median, remember, is our 50th percentile value, our 50th percent place in the curve in the data, right? In this case, the data was not 100. It was a data for 200 days, right? So what's 0.5 times 200? Well, it's 100. That tells us data point 100 is our middle value, or median, right? So data point 100, you go there, go down from there, and you get about 100 and just below 150, right? 146, I'm estimating. That's our Q2, our median value. Try the same thing for the lower quartile. Okay, lower quartile, remember, is 25% of the way through the data. So 25.25 times 200 gives us 50. So at position 50 is 1/4 of the way through the data. And that makes sense. 50 is 1/4 of 200. So you go across from 50, down from the curve there, and you get to about 95 roughly. I'm a little bit beyond 90 there. So 95 is our Q1 value. How about Q3? Find it now. Q3 is 75% of the way through the data. 75.75 times 200 is 150. 150 is here. Go down from the curve. About 215 is our Q3 value. All right, now let's take this a little bit further and see if you can find the outliers. Do you remember how to find outliers? You need IQR, then you're going to multiply by 1.5. Do you remember the process? Let's try. All right, so here's a box plot first of all, based on our minimum amount of visitors, our maximum amount of visitors, and our Q1, Q2, Q3 that we found here. Here's our box plot. And now let's take a look at IQR is Q3 minus Q1, 120. And then remember, you do 120 times 1.5. That gives you 180, I believe, right? So you do Q1 minus 180, and you end up at some big negative value. So that's way down here, negative 85. Well, you're never going to have negative guests, so there's no outliers below that. How about above? You do Q3, 215 plus 180, and that gives you 395. That means you can go all the way to 395 before there's any outliers. But our upper data point was about somewhere here, 360 or more than 360. But it's not up to 395. So there's no outliers. There's nothing beyond 395. No outliers. Okay, now let's talk about something called percentiles. I will introduce this, and then we'll come back to our Haley's Castle where you'll calculate some percentiles as well. Okay, let's talk about percentiles, and here's how they work. Let's say you are the 4th tallest person in a group of 20. This means that 80% of people are shorter than you. So here's you. You're the 4th tallest. There's a group of 20. 80% of people fall below you. That means you are at the 80th percentile. So when I say 80th percentile, it means 80% fall below that place. All right. So that means if your height is 1.85 meters, then that 1.85 meters is the 80th percentile height for that group. Let's take a look at this applied to what we've been looking at with cumulative frequency curves. So the recap here, percentile, the value in the data set below. All right. So which below which p% of the data lies. Okay, that's what we just said. So the first quartile, for example, is known as Q1, and we know it is the 25th percentile because at Q1 we know it is at the 25% mark of the data, right? So that means 25% of the data falls below it. How about the third quartile? Which percentile is it? Q3 is which percentile? Well, it is the 75th because at Q3, remember, 25% of the data is above and 75% of the data is below. So 75th percentile, 75th percentile. And the median is known as the second quartile, or Q2. It is the 50th percentile. Half the data is below it. All right, so let's look at that with this cumulative frequency curve here. First of all, let's answer this starting question. Looking at this curve represents weight data. We can see weight on this axis for how many students? How many students do we have data for here? Do you remember how to get that? Okay, we find that by looking at where the curve plateaus. We look over here, and that is 280, because here's 50, 60, 70, 80. So 280 students we have the data for here. Okay, so now, what is the first quartile weight? Now remember, first quartile means at Q1, right? So where's Q1 and what's the weight at Q1? All right, to do that, remember to find Q1, we do 25% of 280 of all the data. 0.25 times 280 is 70. So we go to data point number 70 right here. We go across, go down from the curve, and that looks like about 69.8. So that is 69.8 kilograms is our first quartile weight. How about the third quartile weight? What is it? All right, hope you got that one to work out. Let's look at the next question. How many students weigh 72 kilograms or less? So now we're given a weight and we want to see how many students that is. So I'm going to go from this axis this time. 72 is right here. I'm going to go up to the curve and then across. And that brings me to about 120. So now I'm saying, what percentile is this, right? So 120 out of the whole group. So I'm going to do that division now. 120 students out of 280. 120 out of 280 gives me a decimal of 0.43. That means that 120 is 43% of the way through the data. Okay, so I am at the 43rd percentile. 43% of data is below me and 57 is above. That is how you find the percentile. Try the same thing here. How many students weigh 80 kilograms or less? What percentile is this? Okay, so I hope you got that one to work out as well. Let's go to the next question. What is the 85th percentile weight? Okay, so now when you're given a percentile, you're looking at this axis again. And just like we were given Q1 or Q3 before, now we're given 85th percentile. So you're saying 85% of the way through all the data. So 85.85 through all the data, 280, multiply them, that tells us 238. So go to 238 here, data point number 238, across and down, and you are at about 78.2 here on the weight. So that means the 85th percentile weight is 78.2. So that means 85% of students weigh 78 kilograms or less. Now, what is the 35th percentile weight? Okay, hope you got that one to work out. Let's try one more application of this. How many students weigh from 65 to 70 kilograms? So now you're saying how many are between a range of weights. So here's 65, here's 70. I'm going to go across on both of those. That one leads me to data point 20. This one, 70, leads me to data point 75. And that means I have 55 students between those two weights. How about students between 75 and 85 kilograms? How many is that? Okay, hope you figured it out. And now we're going to wrap it up by coming all the way back to Haley's Castle. We've already looked at Q1, Q2, Q3 for that using the curve. Now, using the same cumulative frequency curve we have for visitors to the castle, find an estimate of the 85th percentile. What is the 85th percentile for this? How many visitors? Okay, 85th percentile, so we're going to do 0.85 times 200. Remember, we're looking at data for 200 days of visits. Multiply those, you get 170. So that means go to data point 170, which is about here, go across, go down, and it looks like it reveals the 85th percentile is about 247 guests. That means that 85% of days have less than 247 guests. Okay, final question. What is the percentile? Sorry, what percentile is 120 visitors? Find that. Okay, in this case, we begin at 120 visitors here, go up, across, and we get to about 70 on the axis here. And 70 out of our whole 200 is 0.35. That means 120 must be the 35th percentile. Great, I hope that makes sense. We will see you very soon.